2.9 is on gas stoichiometry. We are still in Foundations on Chemistry, Part 2, and we are looking at FC3, using stoichiometry to determine the relative amounts of substances consumed and produced in chemical reactions. We will learn how to determine the relative numbers of moles in a variety of chemical reactions using balanced chemical equations, how to relate the use of the mole to the coefficients in a balanced chemical equation, and compare this to the volume of gases as measurable quantities, and how to perform stoichiometric calculations to predict the outcomes of chemical reactions using the correct units and significant digits. Gas stoichiometry is when we're given a volume of gas in a chemical equation. We can use stoichiometry to find the mass or another gas of a substance or anything, any unit we'd like to convert to, and vice versa. We have the same method that we've used for stoichiometry in the last two sections. We write a balanced chemical equation, identify the given unknown, convert the given quantity to moles, set up a mole ratio and calculate, convert the moles of the unknown to the unknown quantity, and write a sentence answer, or finish with correct significant figures and units. Our first example here, ammonia gas is reacted with sulfuric acid to form the important fertilizer ammonium sulfate. What mass of ammonium sulfate can be produced from 85.0 liters of ammonia reacting at STP? So we have a few key pieces of information here. What mass of ammonium sulfate, and remember that STP, that tells us we need to do a gas conversion. So we first of all start off by writing a balanced chemical reaction. It says ammonia gas is reacted with sulfuric acid. And ammonia is one of those lovely things that has a common name I told you to write down on your cheat sheet. So NH3, or I'll give this to you in a exam situation, or in your practice, I'd just let you know. So ammonia gas is reacted with sulfuric acid plus H2SO4 to form ammonium sulfate. So NH4, 2, well, that doesn't look like a 2, 2SO4. And we need to balance this chemical reaction. If we take a look at this, we have 2 nitrogens, so we'll need 2 nitrogens. Now we have 6, 7, 8 hydrogens, and we have 8 hydrogens and 1 sulfate and 1 sulfate. We're good to go. Because then we figure out our knowns and our unknowns. Because what mass of ammonium sulfate? We go, okay, what mass of ammonium sulfate, that's in grams, can be produced from 85 liters of ammonia from reacting at STP. So 85 liters STP. Which is important because it is liters at STP. It's not a molarity or a volume that we're working with that is a liquid. It's a gas. So when we see that, we know we need to use 22.4 liters per mole. Also, we know when we have grams, or we're looking for mass, we're going to need to find the molar mass. So if we do that here, we need to find the molar mass. This one's kind of a large molecule, so I'll write it down here. We have 2 nitrogens. So 2 times 14.01. We have 8 times 1.01 for hydrogen. We have 1 sulfur, which is 32 0.07, and we have 4 oxygens, so 416. So we have 28.02 and 8.08 and 32.07. I'm running out of room there, so I'm gonna not write that one down. And 4 times 16 is, 4 times 16, 64. So we add all those up. We got 28.02 plus 8.08 plus 32.07 plus 64. You get 132.17. 132.17 grams per mole. There we go. Now we start with the number in the question. 85 liters of ammonia, and we convert it to moles. We know it's liters at STP, so we'll need to use 22.4 liters of ammonia goes on the bottom to get those cancel off, and moles of ammonia goes on the top. There we go. Now that we've converted to moles, we need to use our molar ratio. And for our molar ratio, we have moles of ammonium on top, so we have to put 2 moles of ammonia on the bottom. And we're looking for ammonium sulfate, and there's only 1 mole of ammonium sulfate. So that cancels out moles of ammonia. Now we have moles of ammonium sulfate on the top. We don't want our final answer in moles, so we're going to have to convert that to grams using that molar mass we calculated. 132.17 grams of ammonium sulfate all over a mole of ammonium sulfate. So that cancels out, and we get our final answer. So 85 times 132.17 divided by 22.4 divided by 2, we have 250.769 grams, or 251 grams of ammonium sulfate. The proper significant figures and units. And our next example here, if during the combustion of propane C3H8 10 milliliters of water vapor is produced, how many molecules of carbon dioxide are also produced? Alright, so we have the combustion of propane. For those combustion reactions, we know it's always a hydrocarbon plus water yields carbon dioxide plus, not plus water, wow. Thinking backwards today, plus oxygen yields carbon dioxide plus water. There we go. See, we can make mistakes too. Oh, just gotta figure them out. Hydrocarbon plus oxygen yields carbon dioxide plus water. Now that we've written our equation, we have to balance it. Remember, with these, it's easiest to start with carbons first. We have 3 carbons. I'll write a 3. And then we go with hydrogens for a combustion reaction. So we have 8 hydrogens. We need 8. I have 4. Now we have count of our oxygens. We have 6 plus 4 is 10 on one side. We need to have 5 on the other side. So now that we've balanced our chemical reaction, we need to write our knowns and unknowns. We have 10 milliliters of water vapor, which we need to make sure we write that as liters at STP. And we're looking for how many molecules of carbon dioxide, not propane, molecules of carbon dioxide. Molecules. And we know that if we have liters at STP, we're going to need to use 22.4 liters per mole. And if we have molecules, we're going to need to use Avogadro's number. So now that we've written in all that information, we start with our number in the question. We start with 0.01 liters of H2O, and we convert that to moles using liters at STP per mole of H2O, getting our liters to cancel off. Once you've converted it to moles, we do our next step of using our molar ratio. We have moles of water on top. We need to make sure we put moles of water on the bottom. And we are looking for moles of carbon dioxide, so we have 3 moles of carbon dioxide. Our moles of water cancel off, and we're left with moles of carbon dioxide as our units, but we don't want it as moles of carbon dioxide, we want it as molecules. Remember, there is a difference there. We need to convert using Avogadro's number, so 6.02 times 10 to the 23 molecules of carbon dioxide over a mole of carbon dioxide. And then our moles cancel off. Now we can multiply all of this out and get our answer. So 0.1 times 3 times 6.02 times 10 to the 23, and we get 1.806 times 10 to the 22. If we divide that by 22.4 and divide that by 4, we get 2.02, looking at my calculator, it says 2.0156. Here, I'll write that down for you. 2.0156 times 10 to the 20. I find it easier when you write it down. And we know we need to round to 3 significant figures. Our previous number is 5, so we need to round up. So it goes 2.02 times 10 to the 20 molecules of carbon dioxide. That's our final answer.